Welcome everyone to another awesome show. Innovation Coffee Raspberry Pi Pico Special. Welcome, Robert.
Hello. Welcome, Alessandro. Yeah. Cheers. Oh, yeah, there we go. Clink. It's a good one. This is going to be a very exciting episode, Alessandro. I'm so excited.
It's super cool. So I think before getting started, let's do a quick recap of last week's episode. Robert.
Absolutely. Yeah. So last week, we were joined by one of our esteemed developers, Bruno Verhachten, also known as Podding, from the ARM developer community. Very excited to have him on the show last week. He gave an amazing presentation. I can't even describe it. You have to go watch it. Very interactive, very fun. Lots of good questions from Alessandro, myself, as well as the audience. I'm going to share the YouTube link here in the chat. Don't click on it yet. Wait until after the episode to click on it, but definitely worthwhile if you have an extra hour in your day. You want to spend it watching some really fun and cool stuff from Bruno. Definitely recommend checking that out. Back to you, Alessandro.
Yeah, I mean, today we have the opportunity to actually interview employee number one of Raspberry Pi. So it's gonna be an exciting episode talking about the latest Raspberry Pi board. Robert, do you have a board? I've got a board.
I did bring my board with me. I don't have a Pico. I had to come up with a way to show off a Pico, but I don't really have one. So this is my Pico. Alessandro's sending me one soon, though. Let me put this away.
Put it away, yeah. let's get the actual people that built this board on the stream. So let's bring in Gordon and Luke. Hi, Gordon.
Hey.
Hi, Luke.
Hi, guys.
Welcome.
Yeah.
Welcome to the show.
Welcome. Cheers.
Cheers.
It's a bit late for coffee, but I've got mine.
It's really cool to have you on the show. Thank you for joining us. And I'm really excited about hearing everything about Raspberry Pi Pico, all the behind the scenes, all the reasons why you did what you did. And I've got a lot of questions for you guys, so be ready. And actually, I'm sure the audience has a lot of questions as well. And I just wanted to remind everyone that if you've got questions throughout the show, you can just ask them in the chat and we'll take them on live here. So without further ado, I think it's time to introduce yourselves. So Luke, do you want to go first?
Sure. My name's Luke. I'm a hardware engineer, loosely, at Raspberry Pi. I've been with the company for about 6 or 7 years now, starting as an intern working on kernel. And since then, I've learned chip design on the job. I did a lot of the RTL and hardware design for RP2040. I designed PIO and have done various little software bits on the side.
Awesome. And Gordon?
So my name is Gordon Hollingworth. I am the Chief Product Officer at Raspberry Pi, which basically just means it's a title they give somebody who you can't identify what they actually do. So so you call them Chief Product Officer. But mostly software and I run the shop and do the plastics and that kind of stuff. So it's been a ride. It's been a wonderful time at Raspberry Pi over the last, 8 years going on to. So, but yeah.
And just before the show, we were talking about some of the anecdotes. I'm sure you'll share later, but it's interesting because you both are really, really happy about what you're doing, right? I love that. I love to see how much you're enjoying. Well, no, seriously, like you're really enjoying your job, right? And
my problem is usually working too much, not.
Yes, that's usually the problem. Is I have to tell Luke to go to bed. You are allowed to stop working occasionally. It's fine. But yeah, I mean, how could you not love your job when you get to make stuff like this, right? I mean, it's this stuff and these things, right? So
I think we have someone who would agree with that.
Keep it like that.
Yeah, I should just stay like this for the whole show.
Oh yeah. Make us feel so much more comfortable.
So behind the scenes in the green room, you actually told us something earlier, Gordon. I didn't know this. So you told us that you were employee number one. So actually, I'm keen to hear your, the story behind of how you got to be employee number one. Like what brought you to Raspberry Pi?
So it all started when I was at Broadcom. I used to work at Broadcom with Eben. So I used to sit next to Eben actually. And whilst I was kind of, sat, because we actually worked in quite significantly different areas in terms of the stuff that we did at Broadcom, but we just sat next to each other. And one of the things is, he came up with this idea for Raspberry Pi. Whilst we were there, I saw his kind of attempts to create initial versions of this. And, people may not know this, but the reason it's called Raspberry Pi, people think that pi is because of the number 3.142.159, etc. So, but actually it's not. It's pi is actually Python, because one of the early examples or like little demos that Eben did was it was hang on, I just thought about that. I've got one here. Oh, no, it's gone. No, it's gone. I've got like a demo board that we had that he'd actually ported to run Python on it. And that was his thing. He was kind of like, what we're going to do is we're going to like make these. We're going to give them to kids when they come to, I say kids, students when they come to university. When they then go away for their summer, they can then go learn a little bit more about programming before they turn up. Because a lot of the students at this time, well, like when they turned up, the contact they got with programming was kind of like Java and HTML and CSS. That's what they thought programming was, and they saw this as kind of like the quality of entry, of entry going into Cambridge University. Like they saw this kind of reduction in what people knew when they came in. That was kind of why he did it. So that's kind of what. And then basically, once when it got to 2012 and we launched Raspberry Pi, and I was still there at Broadcom, I was kind of getting to that point in my career where I kind of wanted to do something slightly different, and I just basically badgered Eben to actually make a company that I could go and work for, and we could then do all the awesome Raspberry Pi stuff. And yeah, so on I think it was 1st of January, maybe it might have been the 4th of January. 2013, I sat in Costa Coffee with my phone because I'd lost my phone when I left Broadcom, so I didn't even know. So I had to go. The first thing I had to do was go and buy a phone, and I sat in Costa Coffee and rang Eben and goes, right, Eben, so what are we doing? So, yeah.
That's really interesting. So you are actually one of the reasons why Raspberry Pi exists. I mean, you pushed Eben to actually do it, right? So we can thank you as well.
That was a year after we launched Raspberry Pi. So Raspberry Pi itself was a thing which Eben and the founders, came together to create. And there's a lot of backstory there as to how it was and how it was difficult. I think once me and James got involved, because James also joined around the same time. It just so happens that he was literally like a month later, so he's number 2. So James Adams, who's the COO at Raspberry Pi, he was a month. He's like employee number 2, but. What we did, I guess, is to take, the very first things that we did was to take Raspberry Pi 1 and then turn it into a kind of more usable device. I mean, we turned it into the B+, so the original Raspberry Pi B+, which was a better kind of layout. I mean, it was, you can see that if you look at the different versions of Raspberry Pi now, you can see James's hand in each one of those later versions. And, it took us a long time to get there, but yeah, that's what we did.
Cool. I've got some question later on the different versions and why you chose to do them. But before that, I wanted to ask actually Luke. So we were talking earlier, and you mentioned that you joined Raspberry Pi as an intern. So I wanted to kind of hear a little bit of your origin story on how you got to Raspberry Pi. And I think there's a lot of we've got a lot of students, perhaps, and makers and all sorts of people in the audience that might be interested in knowing, how to work at a company like Raspberry Pi, right? You're on mute still, Luke.
Regular intern programs, and we tend to value people who learn on the job, and we don't really mind what degree background people come from. So I came in from electrical engineering, but went into a software internship. I was at the local university. I knew someone who knew Eben, who posted my CV, and I went for a 3-month internship and wrote a bunch of kernel stuff. And I really enjoyed it. I was going to look at somewhere else for the next year. And then about halfway through my second year at university, Gordon emailed me saying, hey, we're going to make some chips. Do you want to work on those? And since then, I've never worked anywhere else. I mean, this is my first job. My whole career has been so far on RP 2040. And I've really got to know every little detail of this design and
awesome.
Spend a lot of time after work on it as well.
It's one of those things where, like, when you get somebody like that, you're not going to let them go, right? I mean, even if it is like he's a first-year intern, it's like, yeah, but did you see what the first-year intern did? Keep throwing money at him until he comes to join us. Yeah.
In this space, I feel like, Luke, you would be somewhat of a rock star going to a conference. I would imagine that you get some attention.
I've never been to a conference, so I don't know.
Oh, well, I mean, this year and last year you won't get to, but maybe in the future.
The trouble is I haven't been able to talk about the work I've been doing at Pi since its inception, because it's all been super top secret stuff. I mean, we've had to keep our chip design activities under wraps for a while.
Awesome.
We won't ask you those questions.
Robert, I think it's time so we gave a bit of an introduction about Raspberry Pi in general and your origin stories, but I think it's actually time to talk a bit more about Raspberry Pi. But we've got an interesting way to do it. So Gordon, we'll pull up a couple of pictures that we came across, and I'm keen to hear what were you thinking. Robert, are you ready?
I'm ready. It's here.
So this one was like, again, I think probably like it must be like 2013. It could have been early 2014. And the idea was I kind of put a thing out saying, look, why don't you ask me some questions? I will answer them live, and then we'll do a video of this. And this is actually the picture that we then tweeted to kind of go, look, this is what I do. And when I did this, obviously I had to draw something on the board, behind me. So I decided to draw a Raspberry Pi. So that is a Raspberry Pi like version 1. As you can see, the SD card sticks out at the edge. That right-hand side block that sticks out into my ear. That sticks out further than it does on any other thing. Actually, I guess that's the actual SD card sticking out the side. It makes sense now when I say it. But some of the original Raspberry Pis actually had metal SD card slots that stuck out the side because we couldn't actually buy the plastic ones. The inside that, on that board, there is a little picture of the chip, which of course will be, which as you can see, inside there is magic and an arm. And the reason why I put that does say arm. I'm just terrible at writing. The reason why I put that was that realistically, this chip, the chip that we used to create Raspberry Pi, was never made to be in a Raspberry Pi. It was made to go into a mobile phone. And what we did is we kind of squeezed the chip a little bit and pushed. We kind of sneaked an arm into the top left corner of the chip. The whole of the rest of the chip was actually the thing that we were supposed to be working on. And the top left-hand corner was really something we just thought, well, it might give us something that we would be able to do. We might be able to do something with it at some time in the future. Lo and behold, Evan came up with this idea of using it to create a Raspberry Pi, and kind of that's where we ended up. So the magic, of course, is all the other side.
I actually have two questions here. One is, maybe you can squash a rumor for me. I mean, the original ones, they were Broadcom chips, I believe.
Yeah, I mean, they're all Broadcom chips.
They're all Broadcom chips.
They're all Broadcom chips. Yeah.
And these chips, I mean, in the very beginning, Raspberry Pis, I mean, I tell this story all the time, but like I was just amazed at how you were able to get the cost of these Raspberry Pis down so low. Is there any way, or are you able to talk about kind of like the process and how you were able to get the cost of these boards down so low? Okay,
so I mean, the point being that silicon and that chip, you get that from Broadcom. Broadcom make a lot of these chips, so their cost of silicon is really good. So that's one of the issues. The other thing is, what are you comparing it with, right? What am I comparing the chip cost with in comparison to everything else? Well, what you were comparing it with were like TI devices that were sold for like £40. No silicon costs you £40 to manufacture. Well, actually, that's not true. I mean, the bigger you make those chips, they do go up in price quite considerably. Great example of that are the big FPGAs. They really do go up in price quickly. But I mean, the point being that that was, you know, what we were competing against wasn't really, you know, what we were competing against are people who had like a monopoly on these things, and therefore were just selling them at the price that they could sell them at, not the price that they, you know, not if they chose to sell them with a low margin. And that's what we did. And, you know, yes, that was part of it. So the silicon cost made a humongous difference to it. But of course, all of the rest of the stuff, you have to make that board, you have to supply all those components, you have to get, like, you know, the supply chain all working and what have you, to actually start making these boards. And that was a real problem because, you know, to create boards like this, you need to start out by like giving a PO to somebody, right, who's going to manufacture a board. Now, we were going to make 10,000 of these boards. That's all we could make because that's all the money we had. And actually, the thing that really accelerated Raspberry Pi, the thing that really worked for Raspberry Pi, was the partnership model that we came up with RS and Farnell, whereupon we design and we design the Raspberry Pi. We do all the testing, we do all the configuration. We work with Sony actually, but at the very beginning it was a Chinese company. We worked with them to actually get the tests all working. And then what we did is we kind of handed over that as like a package to RS and Farnell, and then they turn up with money and actually get boards and then sell the boards. And because we weren't involved in the money part of this, they then paid us a license, if you see. So we then get a license instead. Because we weren't involved in that money chain of that process, it meant we didn't have to go away and borrow money or raise money to, you know, raise capital to actually get this board into production. And that was probably Eben's like sort of finest, like in that first year, the thing that actually meant it went from 10,000 units to actually 1 million units by the end of that first year. But yeah.
It's crazy. It's crazy. That's like one of, I think, the most notable things that I can remember in 2013, 2012, 2013 timeframe was everyone just exploding about how they can buy a $25 computer. And it was just amazing. I think that will go down in history forever. And then the last thing before we move on to the next picture, you mentioned an Easter egg in this picture. You want to just give a quick?
Yeah, so the top left-hand corner there is, and actually I think that there is a bit more to the left of it, but that's actually me writing up, up, down, down, left, right, BA, which is the Konami code, which is, you know, it's a well-known kind of like a sequence of things that were used on, Luke, can you remember what it was? Which computer system? I can't remember what it was. I think it was a Nintendo. It was. I think it was on Nintendo.
Before I was born.
Sounds like Nintendo.
That is probably true. But what it was is basically we just very recently released Noobs, which was some software that we put onto SD cards so that people could very easily recover, you know, their SD cards. And that was actually, there's an Easter egg in Noobs, which you can trigger by doing that. I say you can, I don't know. I've not tried it in probably about 5 years, and it's quite possible it's a bit rotted away. But yeah.
Noobs was a big deal. A lot of people actually took Noobs and then used it for their own flashing for other boards and stuff like that. So it's a pretty big deal.
Yeah.
But yeah, cool. So this is the next picture, and I think you have a good story to go with this one.
Yeah, so this is again, this is really early on. So you know, we had, you know, right at the very beginning, especially in that very first year, Raspberry Pi won like loads and loads of awards. I'm not sure if this is just normal for like any company when they start up, that everybody wins hundreds of awards. But we won loads of awards, and we had a bunch of people come over to kind of do little bits of interview. And normally what they do is they turn up and they'll interview Eben, and Eben will sit there and they'll just talk to camera, and you know, and Eben does his magic, and he's brilliant at like talking to camera and doing that kind of thing. And this one was slightly different because Eben, I think, just got a bit bored with doing that. And he kind of said to me, he said, well, why don't we just go in there and then we'll just have a chat, and then he can ask some questions and we can just talk about stuff. And that's basically what we did. And I think we even got to the point like where we were talking about space elevators and, you know, all that kind of, you know, random thing, like as you do when you'd like just shooting the breeze between you and your CEO. I mean, that's
very cool. And this video, I'm sure people can go hunt it down, and maybe we'll hunt it down and put it in the description of the video of this video. So let me see. I gotta zoom out, I think, enough so that I can. There we go. Go to the next picture. There we go. And so we'll go to this one now. I think this is really cool. This is a big announcement, I think, in the last couple of years, or last year it was, the year before?
Just a year and a half, I guess. Yeah, the launch of the Raspberry Pi shop. So, you know, so it was my idea to do the shop. I say it was kind of like, again, one of those things right at the very beginning, me and Eben like had this idea that you could, actually, to be honest, it was like let's do a pop-up shop where we just like do a stall, right? And then we'll like sell Raspberry Pis and just be fun, you know, and you just, you know, we'll just do it for fun and that'll be it. And of course, what happened is over like 5 years, that kind of grew. And, you know, I always wanted to do it. And then what actually happened is, I guess the serendipitous thing, which is kind of like, it's not a brilliant thing, but of course what happened at the time was Maplin went bust. It bust or got bought. I think they got bought out. But they closed all their stores in the UK. So Maplin, for those of you who aren't in the UK, is a electronics, like an electronics supply. They used to be able to sell you a resistor if you wanted to. So when they closed, what I actually did is I went to the Maplin shop in Cambridge, and I walked up to the guy at the desk and said, "Are you the manager?" And he said, "Yes." And I said to him, "Would you like to come and work for me?" He was like, "Yeah, why not?" So what I did then is, because he had lots of contacts with people who kind of knew about retail, how to sell computers, how to sell like electronics and that kind of stuff. And what I had was I had like an image in my mind about what I wanted in the shop. And, you know, to be honest, it was mostly about just, you know, those projects, those little stations that you can see on the wall behind me. Yeah, those things there. Which are, the idea is you can just walk into the shop, you can go and stand at one of those, you can follow a list of instructions. The instructions say, you know, press this, click this, open that, and that gives you an idea of what a Raspberry Pi is and how it works. And then the ones in the center, again, are just Raspberry Pi setup, so you can have a little play around and understand what it is. And that's kind of what we did, and you know, love it. I mean, it's one of my favorite things that I've done since I've been at Raspberry Pi, is to be able to make a shop.
It made some good news. I was like, oh, when I went to the UK and I wanted to go visit it, I didn't have time, but yeah, next time.
I'm lucky that I'm in Cambridge and I can go there. Well, whenever I want, when there is not a global pandemic. But yeah, no, it's awesome. It's a really cool shop, actually. I really like it. Cool. So I think we've talked a lot about you know, all this great stuff that you guys have done. I think it's time to talk about Raspberry Pi Pico. So I think it's time to introduce the Pico board. I think we should do it again. Robert, get ready. There you go.
We all have our
Picos on it. Oh, what was that?
I don't have any Picos on my desk. They're all downstairs. I have some other RP2040 boards.
Awesome. We'll talk about those in a second. But I think you guys should give an introduction to the Raspberry Pi Pico. And maybe, Robert, you can bring up the big Pico that you got.
I do have a big Pico here. Nope, that's not it. There we go.
You got, yeah, there you go. Do you want to give a bit of an introduction to the Pico board as a whole, and then we can dig deep dive? There's already a lot of questions on the chat, so I'm keen to get the questions right after you introduce the board.
Yeah, I mean, Luke, do you want to talk about the board?
Yeah, sure. So RP2040 is our new dual-core microcontroller. It's meant to offer a huge amount of RAM at the lowest possible cost and have very flexible I/O. It's a bit light on traditional serial peripherals, but it makes up for it in other ways, and we've got some demos to show that later. And Pico is a platform for that chip. It's a development platform we want to use in education going forward. We've worked really hard on the documentation because we know that if you don't document your features, they may as well not exist. And we've been having fun watching people over the last week start to play with it. I saw someone tweet a camera that they got connected to the RP2040 today through a Pico, dumping images from a camera over a serial port. I think people are having fun with it.
Yeah, I just wanted to kind of add to when you said, documentation. I mean, I was impressed by how much documentation came out on the first day, right? And
we wanted to come out swinging. I mean, like I said, there's no point if you don't document it. So my job for the last 6-9 months has been writing parts of the data sheet and the SDK book.
It's absolutely amazing. And I mean, there is a whole, so this is just a website, right? For the ones of you that haven't checked it out, check it out, because there's a lot of info on there. But then there is a whole where is it? The Pico, I remember getting started with Raspberry Pi Pico, right? This one here is got, opens up a whole other PDF that has a lot of info in here. And not only that, actually, you guys have, I mean, we'll talk about it in a second, but you've done a lot of work with MicroPython, right? And you've created actually a book on MicroPython as well. Is that correct? Is that yeah?
Yes.
So I mean, that's just like mind-blowing. Like all this, usually, when engineers put together things, they're usually not good at documenting it. I think you guys did a really good job at documenting it first, right?
So we identified right at the beginning, and I think it's one of the first things that we said was that, you live or die by your documentation on this stuff, right? You can't not give it away. And the great thing is that the nice thing about a microcontroller is it's so small, right, that you can actually document every single register in that whole thing without having to skim over. You can go through every single thing and what it does and why it does it and all that kind of stuff. So you were able to do it. I think we said from the very beginning that it had to be the most important thing to have that documentation in place. And then that was the number one, was kind of number one had to be in place. Number two was it had to be correct, right? So there's that thing where, like, as an example, generally most of our documentation is automatically generated, right? There is a script that runs and creates that documentation. The reason we did that was because we wanted, we're software. I mean, in the end, we're, even the hardware engineers are software engineers. Let's be honest. We wanted our documentation to exist in text so that we can check it into GitHub and do diffs, right? I mean, that's kind of what we really wanted to be able to do. But also we wanted things like our register maps and all that kind of stuff to be automatically generated from the Verilog, not from a person who reads it from the Verilog and then types it into another document, which obviously ends up with errors when you do that. So that was really important. And the other thing that we did was, not only did it have to exist, did it have to be correct and and perfect and stuff, people had to be able to read it. And that's the reason why we then employed Alistair Allen, who, to be honest, to be fair to Alistair, he's been the guy with the whip who's kind of run around and forced the engineers to actually write up the stuff that they've done. And as you know, like, engineers just don't like doing it, but actually
it's a learning curve.
Once you get them into it, they're actually quite happy, and then suddenly they just go off and they write. And that's what we've ended up doing. Is you'll see, I mean, it must be the last 3 or 4 months of like, you've got maybe 5 or 6 engineers just constantly writing and updating and fixing documentation. So.
One other thing that's a little bit unusual about our datasheet is we have a lot of code examples in it. It's very code heavy, and every one of those, or almost every one of them, is linked to a real example that you can click on the link, go to GitHub and build the code. Partly because that means we can just CI all the code that's in the datasheet and make sure it actually builds. And partly because I think it's really important to get the context for it. Datasheets are really not for hardware engineers, they're for embedded software engineers. So I think it's really important as you read through that you get the code that goes with it. And also, if there are assumptions in the text that aren't made explicit, you can only be explicit in code. You can't just imply things. So I think it's really important that the code shows you how to use the hardware as well as the text that describes what the hardware is.
I will tell you, your your documentation has, in a way, set the example for many of these other board, let's call them board makers out there. I mean, me, myself, working at 96 boards beforehand, like most of these boards over here are 96 boards. I have some Raspberry Pis hanging here too. We went to your documentation for the example on how to build our documentation. We loved how you set your website up and did the whole modify on GitHub thing, and it rendered in from GitHub. There were so many cool things that you pioneered at Raspberry Pi, at least pioneered from my perspective. And I know from many other people who do documentation. I started my career off as a technical documenter. So I have mad respect. Yeah, I love it.
I've got to give credit to Atmel. I grew up on Atmel datasheets, and I loved all the code examples in there. And you can see, like, they show you the ADC, and they show, look, you have this assembly example, this C example, 5 register writes you've done, and you can, if you want to, you can just copy and paste that. It's better than copy and pasting off of Stack Overflow. So
I think that idea of like creating your documentation from GitHub. I mean, I think somebody else had done that already when we did that, and there was Ben Nuttall who was working for the foundation at the time, who actually did the kind of the conversion of GitHub into it. It's really valuable because it does allow people who find errors in your documentation just to click on a link and go, no, that's wrong. And of course, for us, to go back to what we're trying to do, we're trying to create this computer, we're trying to sell it with a very small margin. And the only way we can do that is by keeping our costs low. And one of the ways we do that is by, basically asking our community to help us with things that they can help us with. So, documentation, bug fixing, all of these things. If we do it, it costs you money, right? And when I say you, I do mean that. It's like, if we spend more people doing that stuff, then what it does is it just ends up putting the price up of the final product. And that's kind of the reason we've done that. We've tried to utilize the resources available to us in the world. And of course, you can't do that with Pico because nobody knew about it.
I'm going to jump in and given, I was just going to share an anecdote. When I have to tell people where I work, I usually have to use Raspberry Pi and Arduino as examples so that people understand, what ARM does, right? Because, a lot of people don't actually know about ARM, and then you tell them, oh, Raspberry Pi, Arduino, you know those, right? Like smartphones, and then you get to talk about the chips, right? And I've got, my question for you guys is, why did you pick this particular core to build the RP 4020 or 2040? Sorry.
Do you want to go ahead, Gordon?
No, you go. It's fine.
Okay, so it started with the choice of which ecosystem do you want to be a part of. We chose Cortex-M because at the point where we had to freeze the design at the block diagram level, we looked at a few others. And the thing we really love about Cortex-M is the debug infrastructure, because debug is your eyes into the system in embedded hardware. Debug needs to just be boring and just work. If you try and debug a board and you find yourself debugging the debugger, you tend to just throw it in the bin. So we love CoreSight. One of the things we did early on is try and figure out how to debug 2 cores symmetrically in a microcontroller and expose them as threads to GDB. And that was pretty easy with the existing open source infrastructure they're able to build on top on. We specifically chose the M0 Plus, partly that came from the system architecture. So we wanted to have lots of RAM at a low cost, and that pushes you towards being a flashless microcontroller, because flash isn't just expensive on its own, it makes the RAM more expensive as well because of the extra patterning steps. So we had a lot of onboard RAM, and that means you can have a lot of bandwidth and a lot of fabric ports. And the M0 Plus, as opposed to an M3 or an M4, has just one port with a pretty high injection rate. Whereas an M4 may be getting, maybe 60% throughput on its instruction fetch and a little bit less on the load store port. If you have a certain fabric in the system architecture with a certain amount of memory bandwidth, an M0 Plus just sucks a lot of instructions and code through it. So for a given amount of silicon, we think the M0 Plus, which is a great little integer throughput core, if you push it up to frequency, gets us the most bang for buck in terms of execution bandwidth for some amount of silicon. And the other thing is, because we're on a fairly dense process node, we run the M0 Plus a little bit harder than you might be able to on a smaller node. For us, like the safety and the security of just having solid debug in place already, that was why we made that choice. I think the M0 Plus is a fantastic processor for this system.
Awesome. So I want to move into, I want to keep on schedule. We have roughly 20 minutes left to the stream. There are a couple questions that popped up in YouTube, so let's take those and then let's move into your demo, and then we can get to some more questions right after that. So the first question comes to us from Michael Bishop. Here's a little background. He says, I've been working on the RPi open firmware project a lot lately. This must be for you, Luke. And one of the major blockers I've run into is an undocumented security feature that won't let the ARM control the HVS. Any hints?
I only work on RP2040, so that's a golden question.
That's me. So that's, I don't know. It's interesting because, of course, there is open software that directly controls HVS. So I would suggest you go and have a look at the KMS drivers because in the kernel there are KMS drivers that actually talk directly to the HVS. So it's not that there is a security feature. There must be something else which is wrong there, because there's nothing to stop. There are no blocking. There's nothing there to block it. Yeah.
Okay, so hopefully that answers your question there, Michael. Thank you. This one comes in from Carlo, who is actually from ARM with us. It's a good question though. Still, have you done any DSP voice-based applications using MicroPython on the Pico? I'm curious about how to do more math-wide processes without things like NumPy and other scientific packages.
So we're still bringing that up in MicroPython. If you go look at CircuitPython, then Scott at the moment is doing some really cool stuff with audio over there. MicroPython is kind of the stable conservative port that we're going to keep maintaining and keep documenting. The CircuitPython guys have gone ahead and done some really cool experimental stuff. So if you go check out CircuitPython as well, you might find what you're looking for.
Yeah.
Cool. I mean, we could pull up some stuff here, some stuff like they're excited about Pico, someone's here holding their OG Pi. So, truly amazing documentation. Thank you, Michelle. So yeah, I mean, there's a lot of stuff popping up here. So I guess that's really cool. I don't see any more questions right now. So I think, are we clear, Alessandro, to move into the demo? Luke, are you ready?
Oh, is it demo first or cribs first? We can.
Oh, actually, sorry. We have one more question here that I noticed. And, oh, shoot, there's two more. They popped up. Let's get these questions here real quick. So this one's from Eduardo. What was the overall project budget for doing the RP2040, including all other work needed? And I'm not sure if you're able to answer this, but if you are, sure,
it's not something that we'd be able to answer. But it is. I mean, a project like this is, you're talking about 4 years of work with a team that started out being sort of 3 people, constantly. In the last year, 18 months, that's increased. I guess probably the last year has increased significantly. We've ended up now with more like probably at a peak about sort of 16 to 18 people working on it. That's it's an expensive thing to do in the end, but it's worthwhile. And for us, what it allowed us to do, I mean, one of the reasons we did it was because it's fun, right? And that's a lot of the stuff that we do at Raspberry Pi, we do because it's fun. I mean, you can have a look at all our products and you can work that out really easily. It's fun, and also there are certain types of people and certain specific people that we really enjoy working with, and that we did when we were at Broadcom, and we really wanted to get them back. And that's kind of like one of the reasons we wanted to make chips, is that like we know how to make chips. We did it at Broadcom, and we know the people who can do it. So we're going to get those people and get them, and that's kind of what we've done. So it's been great fun. Yeah.
So this one I feel like is more logistics wise, but I mean, we'll try to get it answered here. Did you rent your ASIC EDA tools, or did you buy licenses? How many seats of ASIC tools did you use?
Very specific.
Sorry, no. I mean, we do buy licenses. I mean, you license licenses. We license all the tools. I mean, that's probably one of the biggest costs for these things. Single, except for mass costs and actually manufacturing. But the costs of this, it is expensive, but those tools do work, and everybody knows how to use them. That there are open tools, as Luke will tell you all about it, for some of the stuff. But in the end, there are a small set of tools that you just have to go out and license and use. So yeah.
I was
Now
going
this
to
is.
sorry.
Oh, sorry.
I was just going to give a shout out to. We also got Kirk Bennell, Chief Technology Officer of SparkFun, actually on watching us, and he's saying that he really liked your documentation as well.
Yeah, I mean, so one of the things that we did do, and people will kind of point this out, is that when we launched Pico, what you notice is that there were a lot of other boards all launched at the same time by other people like SparkFun and Adafruit and Pimoroni and others. And that's because what we did is we created, as we always do, is we create like an alpha test group. So we actually give some of these chips to like a lot of these people. We give them access to the documentation. We have like an alpha test team, which is kind of, this a relatively small group of people that we give this stuff to for them to give us direct responses there, and a lot of those people are on those kind of on the acknowledgements on the original launch page. So and that's kind of that's one of the things that we do. Is one of the ways we've gotten the feedback to get it to the point as well where it is. But it was literally day one, we handed this stuff out, and pretty much everyone who saw it went, "This is amazing, it's so much better." And as Luke will tell you, it got a lot better in the last, 2 weeks? I mean, the difference is night and day in the last couple of weeks.
Long nights. Yeah.
Yes, a lot.
Yeah, I was going to ask you. You probably didn't get to sleep much in the last couple of weeks, right?
And something that's been really fun for the last week is people now live stream reading through the documentation for the first time and hacking on the board for the first time. And what's really interesting is watching people go looking for a feature that they want and fail to find it. Yeah. Because you don't think when you're writing about how people navigate the document, you tend to be quite tunnel vision and thinking, making things accurate, explicit, and clear. But actually, if people can't find it in documentation, it doesn't exist. So it's been really fun watching people find things in the wrong place or not find things where they're expecting, and then going and dropping in sidebars in those places saying, details about this are over there, and making sure the documents are more navigable. I think you can only do that in the age of live streaming, so that's been really fun.
It's been really quite an interesting point, actually, is like you said the other day, you're watching somebody's live stream and they had a problem finding something, and Luke kind of went, "Well, why is it there? It should clearly be here. So what we'll do is we'll just move it." It's like, or like add another pointer so that people can actually find documentation.
A lot of people say we have one timer. By my count, we have 23. But we only have one that says timer in the heading.
Love that. It's user experience research on the fly by looking at people doing live streams. I love that.
You couldn't have done that 10 years ago, I don't think. The culture wouldn't exist and the tech wouldn't.
No, definitely not. Totally agree. And I think that's actually kudos to you for going on to these live streams and, following along, because I think that's a big part of the advocacy, working with developers and evolving and adapting. So this is the last question I want to take right now before we dive into it, because this kind of goes into segue from what Gordon was just talking about, getting these chips into some other board makers, some other manufacturers. Why no board with Wi-Fi? Because IoT is a major part of embedded chips. Now, I know that there are some other variations of, not let's not call it the Pico, but some other boards with the RP2040. I believe there's one that has been said to have Wi-Fi on it. So maybe we could talk a little bit about these variations.
Yeah, I mean, why did we not launch a board with Wi-Fi? Because we needed to launch a board, right? So it's kind of like, we could have done that as well, but it would have just pushed out. I mean, increases all our costs. You would end up having to pay more money for that product than we had. So that's a tax on everyone, because we wouldn't create more than one product. We'd only create one product, obviously, to launch at the beginning. So, we're not going to do everything all at once. I mean, that's the point. There are lots of why not X, why not Y? And the answer is always because what we try to do at Raspberry Pi, and this is like across the board, is we try to create the functionality that 80% of people need, right? Like there are always that extra 20% of products that you want to achieve. There are always other products that you can use to do that. But the point is that what we try to do is well, actually I say 80%, let's be honest, it's more like 95% of products. Pretty much, if you think about what like a Raspberry Pi, like nowadays, you can pretty much do anything that you can do with any normal computer. And the only thing that the only tails of stuff that you're not being able to do are things like, actually significant hard work that you need to be able to do on a computer. But yeah, so that's kind of the thing. I mean, we haven't done it. I mean, that doesn't say we're never going to do it, and it doesn't mean that somebody else isn't going to do it. And quite clearly, I think Pomeroni already have a board. I think Adafruit also have one. I'm not sure exactly what the various different people are planning. But realistically, it's just another chip you stick on the board and talk to it using a serial communication scheme. So there's no reason to actually stick it inside the chip, right?
And I mean, like this particular board, the Pico, can be paired with other boards to give it that connectivity feature, right? So I mean, like adding this to your regular Raspberry Pi, also a viable option, right? If you really want that. So
Okay.
yeah,
Time.
sorry.
No, I was just going to say it's time.
Demo time.
Demo time, Luke.
Demo time. Okay. So this is the board I'm going to use for the demo. It is our VGA reference board, if I can get it to focus. So we have a Pico soldered down with headers. Ignore the big red button. We have VGA, which is just a resistor DAC. We have a micro SD card that's just plugged into GPIOs. And then we have two audio sockets. One of them is just an RC filter from the GPIOs. The other one is from a I2S codec. So I'm going to just plug this in and we'll see what it does. So VGA. I have a bit of a mess of cables on my desk at the moment.
I can hear the noise of all the cables. You're not.
Yeah, there's a lot of stuff here. And power.
Innovation coffee.
So we've posted quite a few demos so far online. A lot of those have been overclocked quite hard. This is something we had running on the FPGA platform at 48 megahertz back in the day. So this is PIO talking to an SD card, I2S, and VGA with the system running at 48 megahertz. So I'm hoping it's going to turn on.
Woo!
So it's an entire media player. There's a little HUD that you can bring up, which I think is, oh no, that one goes backwards. Yeah, it's a bit of a dodgy UI because it's all 3 buttons. So this is Office Space, which I watched hundreds of times during before tape out, because we had an FPGA on my desk that was just running this continuously, and I've watched this film probably about 50 times now. So the way this is working, there are 2 PIO state machines generating the VGA signals. One of them is for color. The other one is for the H-sync and V-sync, and they synchronize with the IRQ flags. There's one PIO state machine that's generating the I2S signals. Someone just said, that's awesome. I didn't write this code. This is all Graham, who's one of our software folks. And then there are 3 PIO state machines that are generating the SD signaling. So one of them is running the clock, the other one is the command state machine, and the third one's handling the data. You can do the CRC16 with the DMA in serial mode. The fun fact about SD in 4-bit mode is that actually each CRC16 is per wire on the bus. It's not a single data stream being CRC'd. So we have to do a software CRC or ignore the CRC for 4-bit mode. This is a custom video compression format. It's per frame. On the original hardware that we ran this on, there wasn't enough memory for an entire uncompressed frame to exist in a frame buffer. So it only ever exists as a compressed data ring buffer. And because it's all per frame, you can go forward frame by frame, or you can play it backward. And that also makes the audio go backwards, which is all being done on the processor. So this is running at 48 megahertz, which is a pretty common frequency for other M0 Plus microcontrollers. We get a lot done, and that's largely because we have a huge amount of memory bandwidth on system. You get one cycle access everywhere. You have the DMA can do 1 read and 1 write per cycle. The M0 Pluses can both do an access per cycle, and we can just shovel a lot of data around very quickly. can play around with it some more, but I think it's, it's something you can genuinely watch a film on, and I have several times. I have a few on the USB cards.
So we have the audience stick around for another 2 hours. We'll watch Office Space in reverse. That'll be.
I hope you guys don't get a copyright strike for the audio there. But
yeah, I was gonna say I think we can only show 15 seconds of that legally.
Yeah. Okay, yeah, might have to mute it.
Awesome.
Yeah, very cool.
That's really, really cool. You had a lot of good comments on the chat. People were impressed.
People are
yeah, commenting. That's awesome. Is that using one core, or is that using 2 cores, by the way?
Oh, you have to use both cores, and the work sharing between the cores is very dynamic in this one because, it's 48 megahertz. You have to output a new decompressed scan line every 30 microseconds. There's a lot of thrashing going on there to make that happen. So that's using, we have great connectivity on the chip. We also have some core local hardware. We call them the interpolators. It's a working title that we never got around to actually changing. That can do fast fixed point maths next to the processors. So we had a lot of fun writing this. I enjoyed watching a film whilst at work every day. Yeah, it's been a fun project.
I mean, it's actually quite interesting because one of the things is that this project of actually playing video, for example, has kind of grown up from, over the last sort of year and a half is Graham and Luke have been working kind of to be able to do this. So they've been kind of making a chip that can do this. And it's simultaneously developing the software that then uses that chip. And they've been doing that because they've been able to run at 48 megahertz on the FPGA. They've been able to actually do it really, in real time and be able to kind of run this on there. And that's kind of one of the great things is we're pretty confident about the kind of the verification of that chip as well, because we've had so much time to do that, right? To actually play with it. But it has been a kind of one of those things where I'm so used to working at Broadcom where verification validation was done, it's much more sort of controlled. It's very much kind of here's a block, here's some test code for the block. Let's put the block into an aggression test system, right? That's all good. Now here's another block, and then we do that. And it was really it was almost like a later thought about whether or not you even connect the blocks together and test them together. We just run the separate blocks at the same time. Surely that must be the same as running everything at the same time. But to actually have somebody kind of sit from software and kind of just hack on it constantly for a year and a half, 2 years.
Graham found a lot of bugs. Yeah.
Yeah.
I don't want to give the impression we've just sent it out without testing it. But a lot of our test coverage does come from integrated system level tests. And we also do something that's not too unconventional, but it causes a lot of bitterness, is we make hardware engineers write software tests for their hardware. Because they have the hardware source open in their text editor still, and they go to write some software for it, and they realize they've done something that's made it really difficult for themselves in that software that they never wanted to write in the first place. So they can think, well, I've got the hardware still open in my text editor. I'm going to go nip back and change that and make the hardware nicer to use instead of writing difficult software. And they really hate it. They don't like writing software, but I think you've got to have a taste of your own medicine when you're designing hardware.
Yeah. That's a really good point. I think, my background is actually as a hardware engineer, right? So I know that very well. And actually, you also have to think about when you're building the hardware, you have to think about how it's going to be tested, right? Aside from the software, there's almost 2 levels, right? It's first you have to think about how it can be tested, and then how you can actually write software for it. So I definitely second that. Luke, we don't have much time left. I wanted to give you a chance to show the other thing you had prepared as well. You have it ready?
So I do have one really quick prototype that I've lashed together basically yesterday evening. So I'm going to just switch to the other input on the monitor.
While you do that, I was just going to say one feature you kind of briefly touched on. Is the PIO, right? I'm really excited about that feature. I think it's going to open up a lot of doors. Right? A lot of people are going to find interesting use cases. Yeah, there you go. Carlo needs to study closer, the feature closer. It's really interesting. Are you going to write more documentation on that? Are you developing more examples?
We have more examples to write. We have a lot more documentation to write on the MicroPython side. I think the documentation is a good first effort, but it's still a work in progress. We focus for now on getting the core functionality there so that people can write programs for it. But one thing I think we need is to make it more nicely packaged, so you can just say, I want a serial port, and get it. And we think that's possible. We think we've laid the right foundation, that we have a stable interface to build that on top of, but it doesn't exist yet.
Okay, awesome. So we can expect more documentation. That's really good to know.
Oh yeah, much more is still to come. So I don't think Gordon's seen this yet. Can I put my screen on share?
Yes, you can. Yeah, you can share your screen if you want. While you do that, yeah. So I think that's a really interesting feature. We were talking about it earlier, Gordon. The fact that it's actually not using the processors, right? It's actually using additional hardware on the chip itself, right? So that's super interesting.
Yeah, no. So because the point is that what used to exist, or what does exist is the idea of bit bashing peripherals, right? If you end up needing a peripheral and it doesn't quite work the way you want it to, or there's some problems or what have you, what you can do is you can take the processor and you can just bit bash the pins to go up and down, and that's basically what PIO does, but it does it using state machines, and it uses a state machine that's programmable with like a very reduced instruction set. To like literally pull numbers out of a FIFO and write stuff out and do lots more. Obviously it does a lot more than just that.
So I think the idea goes back a really long way, like to the 60s, of having essentially a processor, but it's very stripped down for the purpose of I/O. One thing that's kind of interesting about PIO is it's very conservative and traditional in the way it's integrated into the system. You talk to it in the same way you talk to any other serial peripheral. You put stuff in FIFOs, you get it from FIFOs, you get interrupts from the FIFOs, you get interrupts from other things. You hook up a DMA. It's all very familiar, except you can program a small part of it to make all that orchestrate in the right way to do the I/O that you want. So I've got a demo running on my screen right now. It's a very quick prototype. So this is MicroPython.
There you go. This should.
Can you see my screen? Yeah.
Should be able to.
So this is my
background. Yeah.
Okay. So we have a dual core system. In this case, I have one core that's running a MicroPython interpreter, and the other core is bit banging DVI-D video straight into my monitor through resistors. So that's going through the HDMI socket on my microcontroller. Sorry, on the monitor straight out of the GPIOs. So we have 187 kilobytes free. So we're spending a bit less than a third of the system's memory to have the MicroPython interpreter in RAM and all the buffers that are necessary to keep DVI going. You've got to have a new scanline buffer every 30 microseconds. So there's really hard real-time high-performance stuff going on one core in C. And then there's a very rich dynamic programming environment on the other core. I don't have a whole lot to show right here, but I think this is a pretty nice proof of concept that you can have, you can have your cake and eat it. You don't have to choose between having something that's very accessible like MicroPython or something that's very hard real-time high performance.
That's cool.
Awesome. That's really cool. I think Python is a really interesting language. A lot of people are very familiar with Python in general, and I think using it on microcontrollers is super cool. It's it opens a lot of doors. So I'm a big fan of that.
I think we all agree at Pi that MicroPython is a serious tool for embedded programming, just like CircuitPython and NodeMCU. Part of the issue with it is that you tend to need a lot of particularly memory to run it. And generally you have to pay a lot to get that memory, and you get a lot of other things with it that you don't want. So this is RP2B0, which is the second version of the chip. We did an earlier version called A0, which is a test bed for the analog hardware. On that system, we had as much flash and memory as we have memory on B0. It was smaller because flash is more dense than SRAM, but because of the additional cost added by the flash, not just on the flash but elsewhere, you can trade all of your flash plus SRAM for just SRAM at constant cost. So you get total 280K if you include the exit cache of memory. And I think if you ask most software engineers, would you like to trade all of your flash for memory and still be able to initialize it for a few cents worth of silicon? They'd probably say yes. So this is meant to be a low-cost silicon with a lot of RAM.
Awesome. We've got a question from the audience. Will the PIO be able to handle clock stretching on the I2C?
Yes, and there's an example. It's in the dead sheet.
Yeah.
Looks ready for everything.
Yeah.
Perfect. And I was going to say something actually before we close. I was going to say, we were talking about this, Luke, we were talking about this earlier, right? Given that you've been working on this for the last 2 years, and obviously it was kind of, or how many years you worked on this, it was all under wrap, right? And you couldn't talk about it. But, with all the knowledge, to everybody that's watching, if you need, Luke to explain more at a conference, at an event, I think, Luke, you're an awesome speaker, and awesome, seriously, I think.
Well, thanks.
I'm
also around on Twitter if you want to just hang out and ask me questions, or share what you do. I try to be contactable. So.
Awesome. Yeah, because you know so much about this hardware. It's really cool. I think, at ARM, obviously we do a lot of different IPs, and usually the project teams are huge, right? There is a lot of teams that are doing engineering, everything from RTL to validation and so on in software, right? Where I think with a project like this, it kind of reminds me of the first ARM chips, right, that were built, where they were actually kind of smaller teams. Everybody was working on,
It's a little bit skunkworks almost, yeah.
Yeah, I love that though. I love the fact that you've kind of had a chance to work on the whole thing, right? Not just.
So one thing about Pi, we don't keep engineers siloed in one discipline. We let people work on the things that are related in terms of topics rather than fixed to a single discipline. I also don't want to give the impression that I'm the only person who's written RTL on this chip. We have a really small but very talented team, and in particular, we have. We'll shout out Liam. We have great automation for putting the RTL together. So, there's a lot of just rote work involved in designing a chip, and having good automation for it means that small teams can put together fairly complex systems like this.
Yeah. There's another person straight out of university that we grabbed and got him to write some stuff, and then suddenly he's making chips. We're like, oh, great.
Scooping up the talent.
Yeah.
So I want to be conscious of the time here. We are going a little over, and I will say this is probably the highest viewer retention we've had after the top of the hour. Everyone seems to still be here, so I'm sure we could keep going, but I do want to be conscious also of your time, and we are very grateful to have you on this call. Thank you to all the viewers out there. And on a side note, we are 2 subscribers away from 1,000 subscribers. So if you haven't subscribed to this channel yet at ARM Software Developers, go on over after the video, subscribe to the channel, upvote, like this video, and check us out on demand if you missed any parts. Of course, we want to give the floor over to you two if you have any last words, shameless plugs, whatever you'd like to go, and then Alessandro can lead us out.
I think in terms of what we've done, we just want people to go out, as Luke said, we just want them to go out and do stuff with it, and then show us the awesome stuff that they've done. Because we think it's an amazing bit of hardware, and a lot of people have said it's great, but we just want to see what other people do with it.
Yeah, there are already some amazing projects from the community. In particular, things I've seen that are insane to me. Claudius Schwartz on Twitter is working on MIPI CSI2TX, which, if he gets it working, is a 0.5 gigabit serial link to a Pi into the camera socket, which is something you shouldn't really be able to do on a microcontroller. I saw somebody else on Twitter today who got a parallel camera interface working and dumped some images out of it within the day of getting the board. So I think people are already ramping up and doing some really cool stuff. I think in a year's time, I can't wait to see what people have done with it.
I can only imagine.
Yeah, and it's all thanks to the great documentation, right? I think let's highlight that again. I think you've done a great job.
Cracking the whip. Yeah.
Real quick, actually, I do want to say one thing here. For anyone who thinks documentation is not fun, it is a lot of fun. You get to take things. A lot of people always talk bad about it, but you get to take some of the stuff that some of these amazing engineers build, and then you get to test it and find things that are wrong with it, and then document it and put it out there for people to literally consume. So, I mean, like I said, I started my career as a technical documenter, and I had a blast. I've had a blast building documents and doing all this kind of stuff. Again, you get to work with top-notch engineers Here's Ginger here. Love documentation. I mean, if you see a technical documenter role out there and you're thinking if you should apply, it's not technical enough for you, it is, and you'll have a lot of fun. So kudos to all you technical.
It's definitely been a real learning curve for us. It's a completely different skill set from engineering. I have huge respect for people who can do that and do it well.
I think actually, it's as much as anything as well, there's a difference between what makes good documentation and what we probably think we want in documentation. Because of course like, so if like Alistair, whose like background is was actually an academia, he understood what he wanted from the documentation.
That's a good comment in chat.
It definitely wasn't what we thought that people wanted. And I think there is a difference there, that like there's that thing where engineers don't really, they think they know what they want when it comes to things like documentation, but they probably don't actually. So having that like real person to go and to be able to write, to actually use proper words and everything.
I mean, if you spend too long in the system, you tend to forget what's common sense and what's not, and what needs to be made explicit and what doesn't. And having somebody whose job is just to challenge that and make you fully form your thoughts in documentation, that is a whole different skill set, and we really appreciate having Alistair there to do that.
I think you gave an example earlier of you looking at someone going through the documentation and looking for something, right? I think that's exactly how we should always think about documentation in general. Is okay,
it's corridor testing, yeah.
Exactly.
Yeah.
I'm someone that has never done this before. Well, where would I look for X, or how would I do Y, right? And I think that's real user testing is the only way you can actually do that.
Well, we don't know what the answer is. It's Stack Overflow, right?
Yeah, exactly.
You go to Google, you go, how do I do this? And then it tells you, like, then sends you to the Raspberry Pi webpage.
Unfortunately, you can't do that on day one, right? On day one, you have to have good documentation.
We can't preload all our search into Google.
But no, thank you guys so much. And we've actually got a project that we're working on. I'm going to share it on the chat. It's actually a fun demo that we did with the Pico board. So go check it out. It's quite cool. We're going to put a full guide on that video soon. So check that out as well. And guys, thank you so much for joining and for spending time with us and telling us all the background stories, all the anecdotes, and showing us the cool stuff that you can do. And look, now you're actually bringing up block diagrams now. You're late. You should have brought that up earlier.
I thought there might be a chance, but we talked about different things.
I did want to talk about.
I prepared some slides. It's actually running on the microcontroller. I thought that'd be fun.
Oh wow, that's awesome.
Slide deck.
As well. That was a real interesting thing that I found as well. The naming convention.
It's very suggestive, yeah.
Yeah.
No, that. I mean, yeah. Honestly, I could talk to you guys for another 5 hours. Someone did say earlier that they heard us say that we were going to go on all day, and they said, "Really? Can we do that?" So maybe we can invite you next time. We can do a 24-hour show with the Raspberry Pi team.
I think there are people who will agree that I can talk for 24 hours, so it's not really an issue.
I mean, I'll just say Dr. Toon said something that maybe I shouldn't repeat, but you can read it. So, yeah, awesome. Thank you, guys. I mean, it was
thanks for
it was really fun. And thank you to all the viewers for being with us for an hour and 10 minutes. Robert. Oh, we've got someone there.
All right.
Bye, guys. Thank you. Bye, everyone.